Hey everybody, in this video we are going to apply what we've learned about similar solids. So here we have two different cans of peaches, and the surface area and volume of the smaller can are known, and what we're going to do is find the surface area and volume of the larger can. We are given that they have a scale factor of 87 to 100. So we have our three ratios, the similarity ratio, which is the scale factor, the area ratio, and the volume ratio. And we are given the similarity ratio is 87 to 100. Now we can use that to find an area ratio and to find a volume ratio. Okay, so to turn that into an area ratio, we simply take the 87 over 100 and we square them. So it's 87 squared over 100 squared. And I don't particularly want to find and then write these large numbers that we're going to get here, so I'm just going to leave it as 87 squared over 100 squared. And for the volume ratio, it's the similarity ratio cubed, so it's 87 cubed over 100 cubed. Okay, so now we have a similarity ratio, area ratio, and volume ratio. And again, I could actually cube these numbers and square these numbers, but they're going to be large numbers, and I would rather just leave it just like it is for now. Okay, so we're going to use that to find the surface area of the larger can. So to find the surface area, we will use the area ratio. So we'll set the area ratio, 87 squared over 100 squared, equal to, and we've got smaller over larger, so we'll do smaller surface area over larger surface area. And that's 51.84 over a surface area that I do not know. Okay, so we've got a ratio of surface areas. Smaller over larger equals the smaller surface area over the larger surface area. So the cross products are 87 squared times the unknown surface area and 100 squared times the surface area we do know, 51.84. And to solve for surface area, we can divide both sides by 87 squared. And notice I didn't have to deal with any of the large numbers up until this point. And now I'm just going to use the calculator to do it all at once. So we have 100 squared times 51.84 divided by 87 squared. And that is 68.49. So the surface area of the larger can is 68.49 inches squared. Okay, now we'll do the same for volume. So we'll use the volume ratio. 87 cubed is to 100 cubed. So that's smaller over larger. As the smaller volume, 28.27, is to the larger volume that we do not know. Okay, so our cross products are 87 cubed times the unknown volume and 100 cubed times the known volume. And we'll divide both sides by 87 cubed to get the volume by itself. So we have 100 cubed times 28.27 divided by 87 cubed. And we get 42.93. So 42.93 inches cubed is the larger volume. Next, we have a store that sells balls of yarn in two different sizes. The diameter of the larger ball is twice the diameter of the smaller ball. If the balls of yarn cost $7.50 and $1.50 respectively, which ball of yarn is the better buy? So respectively means in this same order. So larger ball is $7.50, smaller ball is $1.50. which is the better buy. So your immediate thought might be that if the diameter of the larger ball is twice or 2 times the diameter of the smaller ball, then the cost should be twice as much. So that would tell you that this larger ball, that's far more than twice as much as $1.50. So that would tell you that's not a good purchase. So the smaller ball is the better purchase. Okay, but let's think about how we can measure the amount of yarn in this ball. Now this ball is a sphere of yarn. So what's happening is we've got a small sphere of yarn and then a larger one with double the diameter. Okay, so we've got our smaller ball of yarn and our larger ball of yarn, and if this one has twice the diameter, that doesn't mean it has twice the volume. So we need to actually compare how these volumes compare to each other. So we have a scale factor or a similarity ratio of 2 to 1. Why? Because the larger ball's diameter is twice the smaller ball. Okay, but it's the volume of yarn in that ball that counts. So the volume ratio is 2 cubed over 1 cubed, which is 8 over 1, which really tells me that there's about 8 times as much yarn in this larger ball than there is in this smaller ball. Okay, so you're getting 8 times the yarn. Okay, so 8 times more yarn in the larger ball, which means that if they're in an even purchase, so that the smaller ball and the larger ball have exactly the same value, then the cost for the larger ball would be 8 times the smaller ball, but I don't think that's the case here. So let's find the cost ratio. So that's one cost over another. Now we've done larger over smaller, so let's do the same here. $7.50 over $1.50. So we've got $7.50 divided by $1.50, and that is 5. Okay, so you get 8 times the yarn for 5 times the cost. So you're getting proportionally more yarn as the diameter increases than you are cost. So the larger ball is the better buy. Now, if you're only going to use a tiny amount of yarn and you don't use yarn very often, so you're just going to have that bigger ball of yarn sit around for $7.50 rather than using the little bit you need for $1.50, you don't want to do that. So get the smaller ball. But if you're going to use all that yarn, get the larger ball. You're getting a much better value there. Let's skip down here and then come back up. What if we wanted a new price for the larger ball so that neither ball would be a better buy than the other? So a new price for the larger ball, that means we're leaving the smaller one at $1.50, and we want a new price for the larger one. Well, if you're getting 8 times more yarn, then to be an even value, you would get 8 times the price. So $1.50 times 8 is $12. So if they were going to be an even value, then the larger one would have been $12 instead of $7.50. Now let's go back here. Cube C has a surface area of 54 square units, and cube D has a surface area of 150 square units. Find the scale factor of C to D, find the edge length of C, and use the scale factor to find the volume of D. So there's a lot going on here, but we have 2 cubes, C and D, and we're going to talk about their ratio. So the similarity ratio, the area ratio, and the volume ratio. So what we are given is surface areas. 54 square units for cube C, 150 square units for cube D. Okay, so if we're going in the ratio of C to D, then we're going to have 54 over 150 as our area ratio. Now, let's simplify that. What goes into 54 and 150? I think 6 does. Let's try 6. 54 divided by 6 and 150 divided by 6 is 9 and 25. So this simplifies to 9 over 25. Now let's turn that into a similarity ratio. We can do that by taking the square root. So the square root of 9 over 25, and that is 3 over 5. So the similarity ratio is 3 over 5. So the first part we're asked to do here is find the scale factor. So the similarity ratio, that is the scale factor. So our first question here is answered. What is the scale factor? It is 3 to 5. Next, find the edge length of C. Okay, so this is a cube, and as a cube, it's a rectangular prism. The surface area of a rectangular prism is 2 times the area of the base plus perimeter times height. Now, if it's a cube, all side lengths are going to be the same. The base is a square, so in this case, it's 2 times the side squared plus perimeter. If the base is a square, the perimeter is 4 times the side length. And then the height is exactly the same as the side length. So for area of the base, it's side squared. For perimeter, because it's a square, it's 4 times the side length. And because it's a cube, all the side lengths are the same, so the height is the same as everything else. So we'll just call that S also. So this surface area formula here for cube C gives us 54 square units. So we have 54 equals 2s squared plus 4 times s, which is s squared. And now we have like terms, 2s squared and 4s squared. So 54 equals 6s squared. And we can divide both sides by 6. And we've done 54 divided by 6 right here, and we got 9. So 9 equals s squared. And the square root, the positive square root of 9 is 3. Okay, so we were asked for the edge length of C. That is 3. Okay, so what we're looking at is a cube. And on that cube, all the edges are 3. So this is cube C. Okay, now we are asked to find the volume of D. So we have found the edge length of C, now the volume of D. Okay, so what we can do here is, first we can find the volume of C. Okay, so the volume of a cube is side cubed. So the volume is 3 cubed. That's 3 times 3 times 3. So the volume of cube C is 27. Okay, and that's in square units, or in just units. I don't know if it's feet or inches, so that's actually cubic units. Okay, so I can find the volume of D using that volume and the volume ratio. So I'll take that similarity ratio and cube it. So that's 3 cubed over 5 cubed. So that's 27 over 125. So the volume ratio, 27, is to 125, as the smaller volume, 27, is to the larger volume, V. Okay, now I could just solve this in my head here. 27 over 125 equals 27 over what? Well, we better get 125. But if we don't recognize that, we'll do our cross products. 27V equals 27 times 125. So those are our cross products. And divide by 27. Okay, once again, there's a shortcut here because I can just cancel out these 27s. Okay, but what if I don't see that? 27 times 125 divided by 27 is 125. 125 units cubed is the volume of cube D.